connector to get communicate with the your microcontroller. Again, GSM module also gets communicate your microcontroller with the serial port. Okay, so we have also given you the type C port, so you can also use this port, connect the cable here and connect it to the PC, and using your serial monitor you can get communicate with this your module. Okay, this module runs on 80 commands, attention commands all that. So you this is SIM 800C module. Okay, so if you go on the net and search for the SIM 800C 80 commands, they will provide you one PDF file, and in that PDF file all the 80 commands of those modules are provided. Okay, so you can issue that 80 commands, and according to you can use this module. Means to send the SMS, there are some sort of 80 commands are there. To receive a call or to make a call, there are some 80 commands are there also there. So, or to connect to the 2G network, let's say GPRS or that, there are some 80 commands are there. To check the signal strength, there are some 80 commands. To check which operators are available nearby, there are some 80 commands. Okay, so according to that, these 80 commands are there. So these are the modules we have provided, and along with that, we have provided for the controller board. We have provided you this ESP32 controller board. Okay, now this is the power supply of the board. 12 volt power supply you have to give here. This is the on off switch. Okay, this supply is then stepped down to the 3.3 volt because your microcontroller ESP32 works on 3.3 volt. Okay, now here again you can see the 10 pin box headers, so on which we have drawn all the GPIO pins of this controller. Okay, here you can see the UXT connector where your UART, I2C and SPI pins are there. Now this controller also have on-chip ADC, and that's why we have given you the ADC pins here and a port test ADC. This is the reset switch for the microcontroller. Then there are two small switches are there. One of it is the reset switch and one is a programming switch. So you have to put this controller in a programming mode to program this controller, otherwise your program will not get uploaded in the programmer. Then here it is a USB to serial converter, and here it is a type C connector. So from this type C connector you can upload the code as well as you can use it for the serial communication. So if you want to see some output on the serial monitor, you have to use this port. Then we have also provided some external ADC, 12-bit ADC and DAC here. So ADC is a 320 MCP3208, ADC is a 3204, sorry, not 320, 3204 4-channel 12-bit ADC. 3 ports and one LM35 is there. Also we have drawn the independent channels of ADC here, and we have given the switches for those. So if you have to use the ports and LM35, you have to put those switches on upward side. If you have to use the independent channels of the ADC and you have to connect some external sensor to it, you have to make it on the downside. Okay, then these are the two turrets for the checking of the DAC output. So from here you can connect the DSO here and check the DAC output. So you can write the code for the sine wave, square wave, triangular wave, sawtooth wave, all those waves, and you can generate those waves using DAC, and you can check those waves here. Okay, now both DAC and ADC are the SPI peripherals, and they share SPI peripherals have 4 pins: MISO, MOSI, SCK and CS. Right? Now CS pin is chip select pin. Okay, so what basically how SPI protocol works is, the MISO, MOSI, SCK, these pins are common between all the slaves devices. Okay, but each slave device should have the separate CS pin. Okay, but here we have the shortage of the pins. So what we have done, we have used the same CS pin and we have given the switch here. Okay, so either the CS pin will go to the DAC or it will go to the ADC. That's why we have put switch here. So to select the DAC or ADC, if it is at a DAC side, DAC will get selected. If it is at a ADC side, ADC will get selected. Okay, we have printed the names on the side of the button, so you can decide which peripheral to select. Then here we have given you the I2C EPROM and I2C, RTC is there, IR sensor is given, and also this ESP32 have some pins that can sense the touch directly. That's why we have given here 4 touch pads here. So you can use those pins and use this as a touch switches. Okay. Then there are general purpose peripherals are there, 16x2 LCD, and this LCD can be used in a 4-bit as well as 8-bit mode, and we have given switches here to change the mode from 4-bit to 8-bit. One precaution you have to take, all the 3 switches should be at the same side to be in a 4-bit or 8-bit mode. Now here we have given that for 4-bit mode 1 and 2 should be shorted, and for 8-bit mode 2 and 3 should be shorted. Now you can see that 3 is written here and 1 is written here. Okay, so 2 is at the middle. So when you shift this button lever at the left hand side, 2 and 3 will get shorted. When you shift this lever at the right hand side, 1 and 2 will get shorted. Okay, so for 4-bit mode, what you have to do is you have to put all the 3 switches in the right side, and for 8-bit mode you have to all 3 switches and the left hand side. Okay, then there is a 4-digit 7-segment display, 2 relays, 1 buzzer, 1 RGB LED is there. Then there is 4x4 matrix keypad, 8 LEDs, 8 switches. Then this is a motor driver. Okay, so but primarily we are using this controller to control these peripherals. Okay, now as you are aware, ESP32 do have its own Wi-Fi connector on board. Okay, so this is a famous controller due to it has a on-chip Wi-Fi peripheral. That's why we are not using this Wi-Fi, we are using its own Wi-Fi connection over there. Okay, so let's see one by one how to connect these boards to these peripherals and how to use them. So first of all, we are going to connect the Bluetooth. So Bluetooth have 4 pins: VCC, RX, TX and ground. So again we are using the serial communication for the Bluetooth. So pin number 16 is used as a RX and 17 is used as a TX, and baud rate is used as a 9600. Then here we have opened the serial port, internal serial port with the 115200 baud rate, and this is the serial 2, so that is BT serial. So hardware we have used BT serial as a serial 2. So this microcontroller has 2 serial ports. Okay, serial 1 and serial 2. So one serial port is used for the programming and serial output, and another serial port is used for the Bluetooth. So we have mentioned here hardware serial, BT serial, and in bracket 2, that means we are using the second serial port for the Bluetooth.
Sir, we are writing the program in C.
Yes.
Same like Arduino.
Yes. To be precise, this is the C++. So then here what we have done is we have this module has built-in LED. So we have set that LED pin as a output pin, and we have to going to control that LED using our Bluetooth. Okay. So here BT serial begin. We have set the baud rate and RxTX pins for the Bluetooth. Then here in a loop function, if some BT serial is available, means we are checking is there something data from the serial Bluetooth, and if Bluetooth has some data, we are going to read it and compare it with the 1 and 2. If one receives, we have to turn on the LED, and if two receives, we have to turn off the LED. Here, while uploading the code, you have to select ESP32 dev module as a board and then upload the code. As I told you, you have to put the controller in the programming mode. So I am pressing this program button, then press and release the reset button, and then releasing the program button to put it controller into the programming mode. Okay.
Is it available in Play Store?
Yes.
BLE.
Anybody of you can be install that BLE scanner app.
I will do.
It's BLE. Actually, Brighton Range కనపడుతుంది.
Hello. Now see, you will see one device with HM soft. That is our Bluetooth device. Now check here, that blue LED is blinking, right? That means it is searching for the device. It is not get connected with any device. Okay, not paired with any device. Now click on connect. Once you get connected, this LED will get solid. That means it gets paired with your mobile. Okay. Now see, go to the custom services. Click on the W button and type 1 and send it. See, this blue LED is turned on. Okay. Now send again go to the right and send 2.
R.
Right. Read, not read. Right. W. 2. See, this blue LED is now off.
We have given command that 1 for on and
2 for off. Yes, exactly. Yes, see, that's what I told you. In the temp, we have given it. This is the temp is equal to 1. Your LED is on. If temp is equal to 2, your LEDs will be.
Can we give letters also? Like if we give A, then it is on.
Yes. You can. Okay. So accordingly, you can control the devices using your Bluetooth.
Okay.
What is this? R and
Read.
And N for?
Read, write.
N for.
No. Okay, notifications. N for notifications.
Notification.
For only this device. అంటే యాప్ కోసం అదేంటిది మరి ఆరు
Read.
డబ్ల్యూ రైటా
Read Is that programs available in Google, right?
No, we have given this the sample program, no? So take this program as a reference and write your own program.
Okay.
So, as I told you,
Then what are these two for? According to this generic access and generic attribute.
no, these are not required.
Not required. Only custom service is
Yes.
required.
I told you, this controller has on-chip Wi-Fi. Okay, so let's check the on-chip Wi-Fi of this controller. So, what this program does is it will scan the nearby Wi-Fi, okay, and it will show you the nearby Wi-Fi networks here. So these are the nearby Wi-Fi networks available here, okay. So their strength is also going to be shown here, and their encryption security levels, okay. So if your known Wi-Fi is listed here, you can connect it to your Wi-Fi, okay. You have to enter your Wi-Fi password name, that is SSID here, your password here, and this is the command wi-fi.begin, okay. So this command will actually get connect your microcontroller to your Wi-Fi network, okay. So do we have your Wi-Fi network?
Yes.
So which SSID we have to connect? SSID?
TP link.
TP
There is no SSID called TP. This one is too weak. It's
Yes.
will not captured by this.
Then
Can you just create mobile hotspot?
Oppo A5.
Is
Yeah. Oppo A5. Oppo.
ఫోన్ ఆడ పెట్టేసి అయిపోతుంది. Oppo A5X 5G.
okay. What is the password?
Password and then hotspot.